Hey guys, so here we have a mass, a 7 kilogram mass, that is being suspended by a balloon with ropes. So in 2A, it wants us to figure out which two forces are acting on this box and to draw and label those forces using arrows showing us the direction. So we are going to draw two forces. What do you think the two forces on this object are? Since it's on Earth, we have the force of weight, and since it's being pulled up by a rope or string, we know we have a tension force. This would be the force of weight. Alright, so we can check that off. The force pulling up is positive or negative? Well, it's pulling the object up, so it's going to be positive. Alright, how much force is pulling down? Well, we actually have an equation for the force of weight. It is Fw equals mass times gravity. And we know the mass to be 7, and our gravity on Earth to be 9.8. Alright, so when we plug that into the calculator, we get 7 times 9.8, which is 68.6. So we know that the force of weight for this object is 68.6 newtons downward, because the force of weight always pulls down. Alright, if the object is suspended, i.e. not moving, what is the acceleration for this object? Well, it's asking for the acceleration of this system. So we used 9.8 to calculate the acceleration of the force of weight. We used the acceleration due to gravity. But for here, it's talking about the acceleration of this system. If it's not moving, the acceleration is going to be 0 meters per second squared. Alright. So put the two forces, the mass, and the acceleration in the following equation and solve for the tension in the rope. Hint, it's not 0. Well, we know that force equals mass times acceleration. And this here is just, it means the sum of the forces. In case you guys are wondering, what is that weird looking E thing? It's the sum of the forces. Alright, we also know that the sum of the forces is equal to F1 plus F2 plus however many forces we have. Now we're dealing with the y-axis here because our forces are going up and down, and we happen to have two forces. So we only need force 1 and force 2. Now, if we know that the sum of the forces is F1 plus F2, and we also know the sum of the forces equals mass times acceleration, what we can do is set these equal to each other. We know that the sum of the forces is F1 plus F2. And we know that the sum of the forces equals mass times acceleration. Therefore, we know that the first force plus the second force equals mass times acceleration. Well, let's go ahead and put in our forces, F1 and F2. We could do either one first, but let's go ahead and do tension since it's positive. We can put tension, and that's a positive tension, and then we're going to add the force of weight. But since the force of weight points down, we know that the force of weight is negative, so it's going to be minus the force of weight. And that equals mass times the acceleration. Alright, so now we can actually plug in our numbers. Tension minus the force of weight, which is 68.6, equals our mass, 7, times acceleration, 0. So we know that the tension minus the force of weight, 68.6, equals 0. So now we just need to solve for tension. We solve for tension by adding 68.6 to both sides. So what we get is tension equals 68.6 newtons up. Okay. Now here it gets a little bit different. If the balloon is actually accelerating upward at 5 meters per second squared, put the new acceleration into the equation and solve for tension. Okay, so now we have the same equation, T, tension minus force of weight, equals mass times acceleration. But here our acceleration changes. It's actually accelerating upwards 5 meters per second squared. Now, since it's upwards, we know that it's going to be positive. So tension minus 68.6 equals, our mass is still 7 kilograms, and our acceleration is now 5 meters per second squared. So when we multiply that out, 7 times 5 is 35, but let's go ahead and plug that into our calculator. 7 times 5 is indeed 35. So we're going to put 35 here. Alright, now if we want tension to be by itself, we're trying to solve for tension, we're going to add 68.6 to both sides. 68.6 plus 35. Alright, let's plug that in. 68.6 plus 35 equals 103.6. So we know that the new tension in the rope is 103.6 newtons. And since it's tension and it's pulling up on the object, we know it's going to be 103.6 newtons up.